We're going to continue now. We've looked at classification of real numbers. We talked briefly about properties of real numbers. And as I mentioned in the initial video, our book, Tools for Mastering Mathematics, provides you with all these details. And this book is provided to you along with this course at no extra cost. There's a PDF, and you can get it right from your Teachable website. When you log in on our website, you will see that in the portal, the Tools for Mastering Mathematics book. If you go to part 2, you will see what you need to know in just I would call them nuts and bolts for effective and efficient mathematics. It reminds you of the properties of real numbers. It reminds you of how numbers can be classified and just things that will be helpful moving forward when you're studying for the ACT and even when you go into calculus and beyond. So now let's talk about factors, factors of numbers. So we talked about types of numbers, real numbers, real numbers, rational numbers, irrational numbers, natural numbers, whole numbers, integers. Now let's talk about factors of numbers. So the factor of a number is basically the factors of a number can be multiplied to give you that number. So for example, 6. The factors of 6 are like you have 2 times 3 is 6, right? So those are factors of 6. By the way, as a side note, 6 is also called a perfect number because the factors of 6, and let's look at a few of them, are we have 1. If we look at the factors of 6, we have 1, 2, and 3. These are all factors of 6. So if you were to add them together, you would have 1 plus 2 plus 3, which is equal to 6. So 6 is also called a perfect number. That's not on the ACT, but it's just a pretty cool fact to remember that perfect numbers have factors that add up to them. And so factors of 6 will be numbers like 1, 2, and 3. We know that factors of 8 would be 1, 2, and 4, for example, and 8, right? And this is the same with a number and 1. The number itself and 1 are typically factors of the number. They are factors of the number because they multiply to give you the number. Now, that is the identity property of multiplication at work too. When you multiply a number by 1, you get the same number. Just like if you multiply a number by 0, you get 0, which is a zero product or zero property. So these are little properties here and there that you'll be hearing me talk about. And you can, again, ask us for any resources on these if you need extra resources. We've talked about factors of numbers. They multiply to give you that number. If they give us a number like 10 and they ask us to find the factors, we know that 1, 2, 5, and 10 are factors of 10. If they ask us to find the factors of 20, we know it's 1, 2, 4, 5, and 10, and 20 are the factors of 20. So it's important to know the factors of numbers. However, now we're going to take a step into what this leads to. So we have factors, and then we need to remember what prime numbers are. So we're going to spend a few moments talking about prime numbers, and then we're going to finish this off by talking about prime factorization. So I have longer videos on prime factorization, but I want to make sure that you're comfortable with working with prime numbers, prime factorization, and factors of numbers. So quickly, we've talked about the factors part. Now when we talk about prime numbers, we're basically dealing with numbers that can only be divided by themselves and 1. However, 1 is not a prime number, and that's important to note. So 1 is not a prime number, but it's also not a composite number. So 1 is not prime and it's not composite. So 1 is left out. So we start with 2. 2 is the smallest prime number. This is very important because 2 is an even number, right? And it's the only even number that is a prime number. So just remember that. That's helpful to know because they can ask you what is an even number that is also prime. So we have 2, then we have 3, we have 5, 7. There is a way to derive these prime numbers, and part of that involves knowing your divisibility rules, which are also contained in the Tools for Mastering Mathematics booklet. What are divisibility rules? If I give you a number, can you tell me if that number is divisible by 3? For example, is 69 divisible by 3? Well, you would say yes, because 6 plus 9 is 15, and because 6 plus 9 is 15, that is a multiple of 3, therefore 69 is divisible by 3. So there's a way to know if a number is divisible by 3. That's not the same way you check if a number is divisible by 4. For 4, there's a different way we find out if it's divisible by 4. So these are just things for you to keep in mind. They'll be helpful in getting you efficient and effective in doing math problems. So for prime numbers, we have 2, we have 3, we have 5, we have 7. Again, if you take a number and you can't find anything that divides that evenly with that number, then we know that that number is prime. If, for example, 7, there's nothing apart from 7 and 1 that goes into 7. So we have 2, 3, 5, 7, 11, 13, 17, 19, and I'll stop at maybe in the 40s. So 23, 29, 31, 37, 41, 43, and 47. So we've looked at a few prime numbers. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. But then we can go into the 30s and also see that 31, 37, and then 41, 43, and 47 are prime numbers. So it's good to just know, I mean, at least the first set here, it's a very good idea to understand how to derive them if you need to. Otherwise, just make sure that you review your divisibility rules. Again, I try to emphasize the name of the topic so that if you ever have to go back to review, you just type in the appropriate topic, or you can email and just ask about, examples and so on with that topic. So prime numbers, is good to know them. That's very helpful. Now we're going to look at prime factorization, because it's one thing to know what prime numbers are. It's another thing to know how to prime factorize. So prime factorization, which actually has implications that we'll talk about shortly before we wrap up this video. So with prime factorization, if they give us a number like 30 and they ask us to prime factorize 30, we would be breaking 30 down into 2 times 15. This is called a factor tree. There's something else called a factor ladder. You can either use a factor ladder or you can use a factor tree. That's how the factor ladder works, where you say 2 and 15, right? 2 times 15 will give you 30. And then we take the 2 and we say, is that prime? That is prime at that point. So you don't do anything further with that part. But then you look at the 15 and you ask, is that a prime number? And the answer is no. So you can break the 15 down into 3 times 5. Now 3 is prime and 5 is prime. So the prime factorization of 30 would give you 2 times 3 times 5. As I said, there are longer videos of this in the course, and you can look at that if you want more details. Looking at the factor ladder, in case you're more familiar with the ladder, we would say 2 goes into 15 into 30 how many times? We say 15, and then we say what is the next number that goes into 15? We say 3 goes into 15 5 times, and then 5 goes into 5 once. So notice you get the same answer, 2 times 3 times 5. So we have both ways, we're getting the same answer. Some people like the ladder, some people like the tree. Whatever method you use, just make sure that you're consistent and that you end with the prime factorization, well, the values, the prime numbers that multiply to give you that number. So these are just short videos to help you review concepts. We've talked about classification of real numbers. We've talked about factors of numbers. We've talked about prime numbers. Now we've talked about prime factorization. And let's just end with implications. So here's what's interesting. If we drew this as a house, you have, right, we talked about numbers as a whole. We need a good understanding of numbers. That is part of the essence of mathematics, as Leonard Euler says in his book, The Elements of Algebra, which is a great book to read, by the way. So it's available in English if you want to read it. Leonard Euler was one of the greatest mathematicians, and he wrote a book where they translated it to English, and it goes step by step into understanding the basics of math all the way to advanced mathematics. So we have numbers, and then we have this pillar here where we talk about factors of numbers, and then we talk about prime numbers, right? And then on the next level of the pillar, we have prime factorization, because we need to understand prime numbers in order to do prime factorization. Maybe here we're going to put classification of numbers. So we have numbers, classification of numbers, prime numbers, factors. Then we have prime factorization. Then we can go up another level and we can look at LCM and GCF. So basically we need to understand prime factorization in order to do well with LCM and GCF. That's the point I'm trying to make. So to conclude this section, why don't we talk about LCM and GCF? So the LCM is the lowest common multiple, and the GCF is the greatest common factor. greatest common factor. So when you're talking of the lowest common multiple, let's have 3 and 6. If somebody's looking for the lowest common multiple, that means what is the lowest number possible that 3 goes into, or that is divisible by 3, but that is also divisible by 6, and in both cases, of course, without any remainders. So when we have 3 and we have 6, if we were to prime factorize 3, we just get 3, because 3 is just 3 times 1, for example. Now, 1 is not a prime number, so we're not going to write the 1 there. We're just going to say 3 is 3. However, if we have 6, we can write that as 2 times 3. So 6 and 3 share the number 3. So therefore, we would write, if we want to find the LCM, we would say 3. Okay, we only write it once because they both share the 3. And then you take this 2 that is by itself and you multiply it by 3 and your answer is 6. So 3 times 2 is 6. The LCM of 3 and 6 is 6. Again, there's more examples we can look at, but I just wanted to show you the connection between prime factorization and LCM. Now, what if somebody says, what is the GCF of 3 and 6? Well, you would still use the same approach, but the thing they both shared, which is the 3, is actually their GCF. So 3 is the GCF, while 6 is the LCM. If you need more examples on this, please make sure you check out the videos for week 1 of the course, where we talk more about prime factorization. Thank you for your time, and I look forward to seeing you in the next video.